Our next speaker will be Dmitriy Beryoza. Dmitry is a senior security researcher with Vector AI, working on threat detection in the cloud and on-premise network. And today he's going to be talking to us about login your own eye, exploiting a stealthy zero network in Azure login infrastructure. Take it away, Dmitry.
All right, thanks a lot. Hello, everyone. Thanks for coming. Thanks. So I'd like to second what the previous presenters said, the presentation right before this one. It's awesome to be back at conferences, and let's hope that COVID soon becomes distant, unpleasant memory. So here are my handles on Discord and Twitter, and my LinkedIn information in case you want to sync up later. I do security research at Vector AI, and as a company we do threat detection in the cloud and in on-prem networks using AI and machine learning. Before that I was a pen tester and secure software development advocate with IBM Security, and before I made a switch to security I was a developer for many years. I'm passionate about all things security, but in particular about reverse engineering, secure software development, and I just love CTF competitions. I live in Ottawa, Canada, so hello from your friendly neighbor to the north. So what are we going to talk about? So I'll start with some brief notes on Azure and Azure Log Analytics. We'll talk about Kusto, which is a query language in Log Analytics, and about how it allows you to query external data, and then we'll jump into how we can actually build a covert channel writing on that. And I'll do a quick demo of a proof of concept code that I built. Then I'll touch on some mitigation strategies and we'll wrap up. So I'm sure you guys know about Azure. It's one of the big three cloud providers. It's massive, been available since 2010. And as of now, it has over 200 services, so it's just gigantic, and it keeps growing, just like the other cloud providers. And of course, these days, security is one of their focal points. They pay a lot of attention to it. They have a lot of security-specific services. And I would say, as far as cloud providers in general, in my estimation, promise of better security in the cloud does hold, but you have to be careful, because when we talk about security in the cloud, there's something called shared responsibility model. And that means that depending on the type of service that you purchase from the cloud provider, responsibility for securing it is either split between you and the provider, or it rests fully on the provider, or it rests on your shoulders as a customer. And that's where I feel most of the breaches actually are happening. It's where responsibility for securing things is on the customer. As far as the infrastructure is concerned, like from what we see in the news, there are not that many breaches that are happening in the core cloud infrastructure, or they're happening and we don't hear about them. They're fixed quietly. There's a stark contrast with how many vulnerabilities are reported for software that's on-prem. But most of the problems occur when customers don't quite secure the functionality that's in their area of responsibility properly. Azure Log Analytics is a log management system in Azure used by many other services, such as Monitor and Sentinel. And it's used to ingest and process logs from Azure itself, from on-prem environments, and third-party logs. So it's really universal in that way. It has a variety of connectors, so you can consume log data from a variety of sources. And it's used by nature, it's used for log analysis, but in particular for security log analysis. As security analysts, the logs are really our only window into what's going on in our cloud environments. So using logs is just invaluable for threat monitoring and incident response. So Log Analytics has something called Kusto. It's a query language. It's a SQL-like query language. I'm not sure why they didn't choose to implement a language with a SQL syntax, but it resembles SQL. If you look at this example here, you will see that it sort of reminds you of SQL. There's a where clause. You can summarize things. You can group things. There are all kinds of operators and functions you could include. So if you know SQL, learning to use Kusto is very easy. I've used it a lot in the past few years, and it's great. The syntax is powerful. You can do a lot of different things. You can do things with multiple tables, and logs are presented as tables in this environment. So essentially, you're building data queries over these different log sources. You could join, you could intersect, you could do all kinds of stuff. And another important feature of it is that it's really fast. I'm not sure how they do it exactly. I think it's just massively indexed on the back end, but your queries are very quick. And that's very important in incident response, because you can almost kind of write queries and execute them at the speed of thought. You don't have to kind of write a query and then wait for it to complete. So that's really important when you're trying to track down a specific incident, breach of some kind. And these queries are used in different areas of Azure. So Azure Sentinel, for example, makes use of some built-in Kusto queries, some queries that community provides, they're crowdsourced, and customer can also write their own threat hunting queries, plug them into Azure Sentinel, run them on a periodic basis. So it's a very good tool for trying to find malicious behavior in your environment. The interesting feature of Kusto is ability to reach out to external data sources. So in this example here, there's an operator that's called external data, and it allows consumption of web data sources as tables in your environment. So in this example here, we are basically loading a CSV file that's hosted on GitHub, and it's presented as a table in Kusto. And you could then join it with other tables to produce interesting behavior. So for example, you could you can consume a list of Tor exit nodes and join that with your table that tracks sign-ins in your environment. And you could have a query that would alert you if there is a sign-in to your cloud environment from a Tor exit node. So you could do some pretty cool stuff with it. This operator supports HTTP GET requests only, and it can ingest data in many, many different data sources. We primarily use it with CSVs, but it could be text, it could be an HTML page. Data sources could be compressed, so it's really powerful. So as you noticed, you just need to provide the URL for it to work. And this was a concern to me. So why is that? This is not a bug, but I think it could be exploited for malicious purposes. And I'll explain as we go along. So malicious user could build a command and control channel riding on this functionality. So you could have commands transmitted over it, malware downloaded. You could exfiltrate data just using GET requests. And in some cases, it's not a big deal, because with zero trust infrastructure, you have lots of remote users that are not only connecting to your cloud environment, they have access to all kinds of other websites. So for those cases, that is not really a big deal, because we've seen malware that's riding on all kinds of interesting third-party HTTP channels. Like the malware command and control centers could be hosted over Facebook, over Twitter. They could be on Google Drive. There's, sky's the limit. So it's not as interesting in those environments, but I think it becomes interesting when you're trying to protect an on-prem network and you're trying to regiment what data sources, what external websites you allow your users to reach out to. So I think that's when it becomes important. So what's the big problem here? So first of all, if someone were to use this functionality maliciously, they would be using legitimate Azure infrastructure. So if you have firewalls in place, you have endpoint monitoring tools, to all of them, it would look like benign use of Azure functionality, and probably would not be raising any alarms. Even more than that, even if you decided to somehow try and monitor that, what do? You'd have to open up encrypted channels and try to filter by specific API requests, which is not a trivial task. So it's not easy to find something like that. On the back end, so let's say you used it to tunnel through Azure infrastructure, and on the exit end, you're, let's say, reaching out to a particular command and control server. In that infrastructure, it would look like request is coming from inside Azure proper, from their core infrastructure. So also not very suspicious. And last but definitely not least, this functionality, Log Analytics, is usually used for threat hunting, for incident response. So it's a security tool. So to me, it feels like, you know, there were these recent incidents where malware was using antivirus update channels to download second stage of malware. So they essentially were using antivirus infrastructure for malicious purposes. So to me, that had kind of feel like that this is a security infrastructure, a security service, and yet there's a possibility that it could be abused. So what's the scenario here? So let's say user is compromised, let's say clicks on some attachment, a malicious email, and malware executes on an endpoint. And that user has access to Log Analytics. Malware could then execute queries through this functionality continuously to reach out to that command and control server. And once the connection is established, data could be exfiltrated via HTTP URLs, and commands and second stage exploits could write down on that channel back to this exploited endpoint. So there's some considerations in play here. So first of all, victim needs to have a Log Analytics reader role in Azure, but that role is not really a high-level role. Many people have it because you're not really changing anything. You're reading logs, and you don't really need access to any log data source in particular because you're not using any log data source. Requests will not work with IP addresses, so hosting your command and control server on just anonymous IP would not work. You need a registered domain, but you know, there were many cases where legitimate domains were taken over and used for malicious purposes, so that's not a big deal. Responses from those GET requests, they could be pretty big. Like in my tests, I could download megabytes of data from those data sources, and that wasn't a problem. But data coming out, by nature of GET requests, they're limited. The URL is about 200 bytes in size, so you really, it's hard to exfiltrate something significant over the channel. You'll have to have a lot of different queries in order to push through, I don't know, the Word document, for example. But you could use it just for critical data. So let's say you're trying to exfiltrate passwords, encryption keys, certificates. So for little pieces of data like that, that would be a valuable tool. Microsoft applies rate limiting to these kinds of queries. So one would have to be careful when executing many of them or executing them at a high rate. So that's something to to be aware of. And so with communication being limited in volume and being victim initiated, you have to reach out to the command control server. You have to have some kind of heartbeat setup so that you periodically ping the server in order to establish a session. And you, because of size limitations, you have to split your payload across multiple requests. So I built a small proof of concept for this. So there's a server in Python. It's hosted on AWS, and a PowerShell client that reaches out to it through this method. Client just runs in the loop. It pings the server periodically. And just to kind of play around, I introduced some delays and jitters so that things would not be as easily detected as automated requests. And requests are encoded as part of a URL path, just as a parameter in the URL path. So client pings the server asking for instructions and ships the data that was, let's say, some private data that it found back to the server. And responses come in the body of GET requests that come back. And it could be a command to execute, a file to download, or a command to exfiltrate something from the client. I compress and encrypt communications with pre-shared key so that you could not easily look inside and maybe try to trigger detections based on that. And I just, to make it look as unsuspicious as possible, I masquerade this as queries to some thread database. So let's say, imagine there's a database that you query with hashes of files that you find, and it responds with information on those files, whether they're malicious or not. So here's some simple communication kind of unpacked. So let's say server is awaiting request. It receives a ping request from the client. Client reaches out, asking for instructions, and the server responds with the following command. So the server, supposedly let's say there's a malware operator sitting on that server, and they say they want to execute who am I command. I mentioned before that because of size limitations and because of the need to maintain a session, you need all kinds of housekeeping data in the request as well. So there'll be you'll need some counters for chunk sizes, chunk numbers, so on and so forth. So there's some housekeeping data added to that command, and then you can encrypt it and compress it, and it'll be shipped in the body of the GET response to the malware on the client side. And once the command is executed, a new GET request is sent to the server with the result. So in that case, it's my username as a result of who am I command. And then we compress and chunk the data as necessary, and base64 encoded because it has to encode it like that in order to be a part of the URL. So at the bottom, you would see how it looks like when it goes back to the server. So let's see. OK, all right, that's encouraging. So let's start the demo. So this is a demo of how this actually looks in real life. So on the left, you have a server in the cloud, in AWS, and the victim machine running the PowerShell. Come on, you can do it. All right. All right, so the server is starting. Then the client. You can tell I can type very well. So you'll see a little heart symbol blinking there. It means that the communication is established, and the communication goes through Azure, through Log Analytics, through that channel that's established there. So it's sending heartbeat requests, requesting commands. And operator on the server asks to execute a who am I command, and that's what the client does, and that's the response. So it's for small requests, it's pretty fast. Then we'll try to exfiltrate a file. So on Windows, there's this small text file that's out there on every Windows machine. It's very easy to find, and it's very small, so it's good for testing. So you could either use the type command to dump its contents, or I implemented an upload command to actually steal binary files from the client if necessary. There's just, you have to be mindful of how long that takes because of the 2000 byte limitation in the URI. You'll need many, many requests to transfer a large file. And finally, we'll download malware from the server to the client. Let's just give it a second. So we say we need another DLL that contains some other malicious stuff. And because GET responses, the size is pretty much, well, it's not unlimited, but you can transfer significant chunks of information. The download to the client goes very, very quickly. So this is how it looks in action. All right. So let me see. Nope. Let's go to the next slide. Come on. All right. So you may be asking why implement C2 channel from scratch. It would be a valid question to ask. There are a lot of C2 frameworks out there, and I actually tried to implement this with Cobalt Strike with a malleable profile. Most functionality is available in CobbleStrike, but there are some limitations that could be bypassed creatively. But unfortunately, some other limitations, they ended up being roadblocks. It imposes restrictions on URI size, on header size. It needs multiple URIs to actually implement a proper beacon. So with CobbleStrike out of the box, it didn't quite work. However, with some code modifications, I don't see why you couldn't have a CobbleStrike beacon or some other C2 framework beacon implemented based on this, or integrate this with Metasploit or any other frameworks. So as a defender, how would you address something like this? So first of all, for this to work, you need your victim needs to have access to log analytics. They have to have either log analytics contributor or log analytics reader role. And not everybody should have those roles. As a matter of fact, even ignoring this scenario, your logs are just treasure troves of all kinds of interesting information. They're just very valuable for recon. If somebody wanted to learn about your environment, sometimes there are keys or passwords dumped into those logs. So in general, you shouldn't give this role to just anybody. It should be a restricted set of people to get this role. And Azure fairly recently introduced a way to monitor your log analytics queries. There's actually a separate log to log those queries. That's kind of recursive. So the query you run on the logs gets added to the log. But there's this log where you could see what somebody is doing in your log analytics environment, what queries are being run. So maybe you could look for some patterns in that table. I thought that, there's no reason why this functionality should be wide open, so I actually proposed to Azure that maybe we should restrict this a little bit and just give sort of a whitelist functionality to administrators where you only define the websites that you really need to reach out to using this external data operator, and everything else would be prohibited. So Microsoft looked at it and said, no, we don't want to do that. So, okay, that's fine. They weren't as impressed. But I think the issue here goes beyond this particular issue. Cloud offerings are just growing at amazing pace. So Azure is over 200 services, AWS over 200 services, GCP over 100 services. So almost weekly or monthly, something new is being added. And you can bet that in other services, in Azure and elsewhere, you could have similar functionality, unrestricted HTTP requests going to wherever you want, basically. And you could have malicious functionality riding on that. So I think it's just something for cloud providers to keep in mind, maybe do something about it. There are all kinds of database services, big data, analytics, automation, you name it, that could have similar functionality that could be abused for hidden C2 channels. So it's something I think should be included in cloud providers' threat modeling, and same thing for their customers. So to wrap up, so we saw how some cloud functionality, even though it's behavior by design, it's not a bug, could be abused for stealthy communications. I think it's, as I said in one of the slides, it's a threat not only because of the stealth, it's hard to monitor, and also it's Azure APIs, they have an air of legitimacy to them, so somebody using the API for malicious purposes is not a red flag. So it's something that's easy to overlook. And also, this functionality is specifically used for security, for threat hunting, for incident response. So for it to be abused in this way is sort of unexpected. This is not where you would look for your threats. So that adds some additional gravity to this. There are ways to restrict this, particularly by not giving away log analytics reader roles to just anybody. I think it should be a restricted group and to monitor queries. And I think there are similar opportunities for abuse elsewhere. I think it's it's something to think about. Do cloud providers basically have these opportunities for covert channels tunneling through them that are hard to monitor? And that's the end of my talk. And if there are any questions, I'll be happy to answer them. And thank you guys for listening. Sure.
Are you releasing your content on GitHub or anywhere?
I wasn't sure it would be interesting enough, but since you're asking, yeah, the slides will be here, and I'll add a link to the code there as well in a few days. Give me a few days.
Thank you.
Okay. Well, I'll hang around in case somebody wants to talk. Thank you, guys.